Hi everybody, Mr. Rubo here. Today we're going to talk about exponential function, context, and data modeling, which is 2.5. But before we can even get into the context, we just have to know something about our data, which in general, exponential functions, you can see if they're exponential, seeing if there's a proportional growth pattern to the y values, right? So in other words, they're doubling, tripling, or halving each time, right? So it's that multiplication, but sometimes it doesn't appear with the y values initially. And this is due to a vertical translation. Okay, if you have a vertical translation of the function, it then makes it so it looks like it doesn't multiply by the same thing every time, but it actually does still follow an exponential pattern. So, and we'll see examples here, but the way we fix this is by either adding or subtracting a constant. Constant. From the outputs to then reveal our growth pattern. And then the initial function was also exponential. So good example here is a. So for this one, they're even telling us this is exponential, but when you look at this initially, you're like, okay, equal length input values, intervals going up by ones, but then my y values, well, 7 to 13 doesn't multiply nicely. 13 to 25 is not the same multiplication as 7 to 13 would be anyways. So this is where we have to look first at their first differences. Just like we would if we were checking to see if it was linear, we're going to go ahead and do this. And we're going to see that this will reveal that it is actually exponential. So 12, and then 24, and then 48. Well, if you notice, these differences are all being multiplied by 2. And there's our common ratio is multiplying by 2. But now the problem is, how do we write the function based off of this? So what we're going to do is we're going to write, we're actually going to come up with a system. So we're going to say, we're going to start with our normal function value. Now, I guess I should also mention, hey, it's all being multiplied by 2. So that means our b value is 2 to the x, or our b is 2, and then it's to the x. And then the problem here is we don't know what this a value is. We don't know what our initial would be. We also don't know what our vertical shift is. We have to find those two things. Okay, so what we're going to do is we're going to choose 2 points to plug into this function. I'm going to choose the first 2. So I'm going to plug in 0 and 7. So I'm going to say 7 equals a 2 to the 0 plus d. And I'm going to simplify this a little bit. 2 to the 0 is 1. So I get 7 equals a plus d. And I'm going to solve for d. I'm sorry, actually I'm going to solve for a. So I'm going to say 7 minus d equals a. Okay. But it's a system, which means I need a second equation, which is where the second point comes in. So I'm going to do the same thing, but with 1 and 13. So 13 is the y value. We don't know a yet. 2 to the first plus d. This I can simplify, so I'll get 13 equals 2a plus d, and this is where solving a system comes in. I'm going to substitute. I'm doing the substitution method. I'm going to substitute in 7 minus d in. So I go ahead and I plug it in and simplify, and eventually as you solve this, you will get that d equals 1. Okay, if you don't get d equals 1, double check your math, but you get d is 1, and then we can actually figure out what our a value is by substituting it in to this guy. So we get 7 minus 1 equals a, which means a is 6. Okay, and now we have our function. So our function, our final answer is f of x equals a, which is 6, and then 2 to the x plus 1. And again, just to kind of make sure you see it, you can plug in the values. But the whole idea of like, okay, we had a translation of up one, which means if you subtract one from all of these numbers, you will see the exponential pattern, right? If you subtract one, you get 6. Subtract one from 13, you get 12. You actually end up getting these numbers. It's not always the case that you get these numbers specifically, but it is what happened here. So yeah, here is our function, and there you go. Got to do a little algebra here, but it's usually nothing too bad. So yeah, thanks for watching. Have a good day.